Section 10.1, radical expressions. Radical expressions are those square root, these boxy things. And the first section in your homework says, but I'm going to actually kind of walk you through the different types of sections that your homework has. So pay attention here. The first section simply says, find the nth root. Now here's the crazy deal. If I say, find the square root of, say, 16, if I say find the square root, what is the square root of 16? Then the answer is either plus or minus 4, because 4 squared is 16 and negative 4 squared, negative 4 times negative 4 is also 16. So in that section, they want the answer. I want you to give me the answer of plus or minus whatever this is. Now, if you've got an odd root, and I think in your homework they're all square roots, so the answers will all be plus or minus, hint, hint. If you've got a cube root, though, then whatever the sign is under the of the number that you're taking the square root, then it's going to be that answer. So, but for right now, if you want the square root of a number, then the answer is plus or minus. Now, here's where it gets weird, because in the next section, when I say, what's the square root of 225, and I use the square root symbol, then we're just going to assume that we're talking about just the positive answer, okay? So so in the first section, I want the answer plus or minus, but in these where I say, I give you the square root symbol, we're just looking for the principal square root, which is just the positive square root, so don't worry about the plus or minus in the sections after that first section, okay? So the square root is the number that you take. What number do I take times itself to get this number? And that's where we got the 4. What times itself equals 16? Well, 4 times itself. 4 times 4 is 16. So in this case, what times itself is 225? Well, sometimes if it's a large number like this, if it helps if you break it down into its prime factors. So 225, we can take 5 times, what is that? I should have done this ahead of time. 45, is that right? And then 45 is 9 times 5, and 9 is 3 times 3. So we've got 3 times 3 and 5 times 5. And then if we want the square root kind of takes things out. It takes things out in pairs. So it's going to take a 3 out, and it's going to take a 5 out. So it's going to be 3 times 5, or 15. So 15 times 15 is 225. All right. Now, the same type of thing with 81. Now, some of these smaller numbers, if you just recognize, oh, well, 81 is 9 times 9. I know that. You can simply recognize that and be done. Or if you need to do your tree, then you would get down to 3 times 3 times 3 times 3, and it's 2 sets of 3. So 9 times 9 is 81. So you'd have a 9. Now, if you've got the negative on the outside of your square root, what this is saying is I want the opposite of whatever this square root is. So if the square root is 9, I want the opposite of it, so I want the answer negative 9. Okay? If you want to work it out, let me show you. So 81, if the tree is 3 times 3 times 3 times 3, so you've got 1 set of 3s, 2 sets of 3s. So that's where we've got 3 times 3 is 9. That's where 9 comes from. 9 is simply 3 times 3, but this is huge, huge, huge. Make a big old note of that. If you've got a negative number under the square root, there is nothing that you can take times itself to get a negative number. If any time you multiply the same thing times itself, if a positive is times a positive, your answer is positive. If you take a negative times a negative, your answer is also positive. So if you've got a negative under that square root symbol, your answer is no real numbers. And later on, we'll get to imaginary numbers. But for right now, your answer is no real numbers. Be careful, okay? Watch for that. If the negative is under a square root, no real numbers. Now, if you've got plus or minus the square root of 121, well, 121 is 11 times 11. So the square root of that is just 11. But we want plus or minus. If they say, I want plus or minus whatever is in that root, then your answer is plus or minus that root. All right. Now here it gets a little bit tricky. Of course, I'm going to get trickier and trickier as we go. This is a cube root. If you've got a 3 on the outside, all of these have been square roots, and they've been we just understand that there's a 2 there. All right. So if there's a cube root, what that means is now instead of taking a group of 2 out, we've got to have a group of 3. All right. So 8 we know is 2 times 2 times 2. Right? And if you do your tree, 4 times 2 is 8, and then 2 times 2 is 4. So in order to take something out of a cube root, you've got to have a group of 3 numbers. And that's what we have here, a group of 3 numbers. If you have a group of 3 numbers that are the same, you can pull them out of that root symbol. And so your answer is just 2. All right. Now, here's something else. We've got a negative under this root symbol, but if you'll notice, this is a 3. This is an odd root. This isn't a square root. This is a cube root, a 3 root. All right. So if you take negative 2 times negative 2 times negative 2, negative times a negative is a positive, times another negative is a negative 8. So negative 2 times negative 2 times negative 2, all 3 of these are exactly the same, and multiplying all 3 of them together gives us what is under this cube root. So my answer is a negative 2. So here's the generality, something you can write down in your notes. If your root is even, you cannot have a negative under the root symbol. If your root is odd, then your answer will have whatever symbol is on the number under your root symbol. Okay? If your root is odd, you can have a negative. If your root is even, you can't have a negative. Easy sneezy? All right. The 4th root of 16, so now this is an even root, so with a fourth root, you couldn't have a negative. Now in this case, it's not a negative. And 16, if we do our tree, 16 is 4 times 4, and 4 is 2 times 2. So 16 is 2 times 2 times 2 times 2. And because we have a 4th root, just kind of like the 3rd root, we're going to the 4th root. So in order for something to come out of that root box, it has to be a set of 4 that are exactly the same. So all 4 of these 2's can come out as a set. It's almost like, I call this go fish. It's almost like you've got all of these, you've got to have a set of 4. If you've got all 4, then you go fish. Or you don't have to go fish. So you put all 4 together, and you know how you stack them up and you put them down with just one of them on top. So you stack all 4 of those 2's together, and on top you just have a 2. So you just have 1 2, but it's not in the square root anymore. All right? Okay, so lots and lots of those, just examples. There's some examples. If you put those in your notes, then as you come to them in your problems, that should help you. The next section in your homework says to use your calculator, and what they've done is they've said, what they've done. Let me give you the example of just the square root of 19. So the square root of 19 isn't a perfect square, but if you put that into your calculator, and I think most of you have the iPhone calculators, and so if you just flip it over, it's not going to work right side up, but if you flip it sidewards, there is a square root button, and there's actually a button that has X with a square root and a Y up above it, so you can do more than just the square roots. So if you can't find that button, ask me in class and I'll show you. So what you do is first you press the 19, you press 19, and then you hit that square root button. If you have a scientific calculator, then you actually press the square root button first, and then you're 19. So if you're confused about what to press, then make sure to see me in class. It's kind of hard to do that on a video. But if you just press 19 and then the square root button, you should end up with 4.35, and it goes on and on and on and on. So round it, I think your book says to round it to 3 decimal places. So that's all you'll do on that. I think I have 3 or 4 of those. Just push them into your calculator and easy sneezy. Okay, next section is if you have variables. If you have variables, it's the same as if you had numbers, but you're just going to have the variables sitting there. So x squared is x times x. And so play and go fish, there's 2 of them that are just the same, and our root is a 2, so x is our answer. Okay, so if you get a pair, you take the pair out. If you don't have a pair, it has to stay in. So in this case, you can do it a couple of different ways. I'm going to show you if you've got, you need to have two that are exactly the same. So if you can split this up into a to the third times a to the third, now those are exactly the same. So a to the third will come out. All right, so remember, because 3 plus 3 is 6. So you add these exponents together to get your exponent. So you've got a to the third. Now 16 is 4 times 4. And again, I'm taking out things that I know, even though these aren't all the way down to the prime factorization. 4 times 4. And x to the 8th is x to the 4th times x to the 4th. So here's my two pairs, and so a pair of 4s and a pair of x to the 4ths will come out. All right, so you're trying to divide it up into pairs that are exactly the same. All right, same thing here. 25 is 5 times 5. There's your pair there. X to the 8th is x to the 4th times x to the 4th, and we just did an 8th up here. And y squared is y times y. So then we have a pair of 5s. We have a pair of x to the 4ths. And we have a pair of y's. So if you have a pair that's exactly the same, then you can pull it out of the box. All right? This one's a little bit trickier because you need 3, not just a pair. You need 3 that are exactly the same. So here, it might be helpful. Now, we don't want to write 12 x's. You can x, 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 x. Whoo. But what you could do in this case, it might be more helpful to put them in groups of 3. So x to the 3rd, so there's one group, times x to the 3rd, there's another group. So 3, 4, 5, 6, so there's 2 of them. And then x to the 3rd, 3, 4, 5, 6, 7, 8, 9, and then another x to the 3rd. So each one of these, and what I've done, so I don't confuse you, what I've done is each one of these is a set of 3 x's to make up 12. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 12 x's sitting here. What I've done is I've put them in piles of 3 by doing this. X to the 3rd, there's 1 pile of 3. There's 2 piles of 3. There's 3 piles of 3, and there's 4 piles of 3. So now I have 1, 2, 3, 4. Okay, so this is three x's together. So what I have now is x to the 4th that's not in the box anymore, because there's this x to the 3rd represents one set of x's. Okay, so there's an x, an x, an x, and an x. 1, 2, 3, 4. So that's where I get my x to the 4th. Okay, if you need to come and see me in class about that one, be sure to do that. If that makes sense to you, then great, let's move on. Last section is evaluating square roots. And you've evaluated functions before, and so this just is exactly the same thing. They're going to give you a puzzle piece. You put the puzzle piece in, and then you work it out. You work out the problem. So in this case, they give you the function is the square root of 3x minus 2, and they want you to evaluate the function for 3. What this means is, wherever you see an x in this problem, you're going to replace it with a 3. So you're going to put your 3 times this x becomes 3 minus 2. So now just work it out. 3 times 3 is 9. 9 minus 2 is 7. And then you look to see, can I take the square root of 7? Nope, I can't. So the square root of 7 is your final answer, just like that. All right, one more. In this case, we've got the function of x is the square root of 2x minus 6. I want to evaluate at the function is 0. So remember, for every x, you're going to replace it with a 0. So I'm going to take 2 times 0 minus 6, and don't lose your square root symbol. 2 times 0 is 0. 0 minus 6 is just negative 6. And now I have the square root of negative 6, and I can't leave that because, remember, there's a negative under that square root. So the answer here is no real numbers. And that is your final answer. Okay, so a lot of stuff. I think you've done some of this before, so hopefully it won't be too overwhelming and cumbersome. If there are parts that don't make sense to you, please make sure to ask me in class, and I'll see you soon.